Okay, so this video is going to go over the Unit 4 Lesson 2 from Thursday, November 19th, solving systems of linear equations graphically with special solutions. Okay, so will systems of linear equations always have exactly one solution? The lesson we did the day before this, they always intersected just once and had one solution. Today we're going to look at some examples where that might not always be the case. So for our first investigation, we're graphing these two linear equations. So in the first one, our slope is negative 3 over 2, and our y-intercept is 7. That means we're going to begin at 0, 7, and we're going to move down 3, right 2, based on our slope. Okay, that's for this one. Okay, so let's go ahead and graph that. I'm going to begin at 0, 7, that's my y-intercept, and I'm going to move down 3, right 2. Down 3, right 2. Up 3, left 2. Okay, this is my first linear equation. Okay, and my second one, the y-intercept is 1. So we're going to begin at 0, 1. And our slope is negative 3 over 2, which tells us to move down 3, right 2. Okay, so for this linear equation, I'm going to begin at 0, 1. And I'm going to move down 3, right 2. Down 3, right 2. Down 3, right 2. Up 3, left 2. Up 3, left 2 to go backwards. Connect them. Label them. So this one was y equals negative 3 halves x plus 7. This one was y equals negative 3 halves x plus 1. Okay, so find the solution. Well, we learned yesterday you have to look to see where they intersect. And it doesn't look like these two are ever going to intersect. They're parallel lines. They're not intersecting ever. They're not going to cross. So let's just write down some notes here. We see that these are parallel lines. So there is no solution. Parallel lines, they will never intersect. And they have the same slope. That is what makes them parallel lines. So that's really important to identify. Okay. Now let's look at the second investigation. Let's just emphasize no solution to this system. Now let's graph these two. Okay, so the first one, our slope is 3, as a fraction is 3 over 1, which means we're going to go up 3, right 1. And our y-intercept is negative 2. So that means we're going to begin at 0, negative 2. So let's go ahead and do that. Begin at 0, negative 2. Move up 3, right 1. Up 3, right 1. Again, our slope of 3 is 3 over 1. So we're going up 3, right 1. We can go down 3, left 1. And that's our first line. All right, now let's look at our second line. So this is y equals 3x minus 2. Our second line is not in y equals mx plus b form. It's not in that slope-intercept form that we need it to be in to figure out the m and the b. So we're going to have to move some things around. All right, so we want to get our y by itself. So it's y equals mx plus b. So I'm going to move my term negative 6x to the other side by adding 6x. Now I have 2y equals 6x minus 4. I'm writing my 6x in front of the minus 4 because we want it to be in y equals mx plus b form. So the term with the x has to be in the front. We need that y by itself, so we're going to divide by 2. Divide everything by 2. Then we'll be left with y equals 6 divided by 2. So let's see what we get when we do that. You're going to get 3x minus 2, because negative 4 divided by 2 is 2. Okay, so that is our second linear equation. This was our first linear equation. What do you notice about those two? If I take my blue marker and I graph this one, negative 2, begin at negative 2, and move negative, I'm sorry, hold on, let me write that out. And move 3 over 1, up 3 over 1, up 3 over 1, we're going to get the exact same line. So, well, I'll color that one blue too. Y equals, oh, well, actually, we're going to write this with the original, which was, sorry if you can't see, negative 6x plus 2y equals negative 4. So even though the equations looked different at the beginning, they actually turned out to be the exact same line once we moved terms around to make it in y equals mx plus b form. It's like one line on top of the other. They're the same line. So if a solution is where the two lines intersect, looking at these two, they intersect here and here and here and here and here. And in between all these points, they intersect here, 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 here. They intersect everywhere. They intersect infinitely many times. So what is the solution? There are infinitely many solutions. And why is this the solution? It is the same line. They have the same slope and y-intercept. Exact same line. Okay. The next page is all just notes. Okay, so we're reminding you the equation is y equals mx plus b, the equation of a line. So here's an example where you have a unique solution. You have one solution when they intersect, no solution when they're parallel lines, and an infinite number of solutions when the one line is on top of each other. The lines are the same line. Okay, so here's a little graphic organizer chart to help you figure it out. So it's going to have the system's going to have one solution when there's one point of intersection. This happens when the slopes are different. Anytime the two lines have different slopes, they're going to intersect once. The y-intercepts can be whatever they want. Same, different, doesn't matter. Different slopes means they're going to intersect once. One point of intersection. Okay, so what you can look for on your graph, you're going to look for two lines that are intersecting, and you're going to look for different slopes. Here's an example. These two have different slopes, and these two have different slopes. All right, so I'm just going to circle our slopes. Different slopes means one solution. Okay, what about no solution? No solution means that there's no point of intersection. They're never going to cross. This happens anytime the slopes are the same, but the y-intercepts are different. Okay, so different slopes means one intersection. Slopes are the same, y-intercepts are different, means no solution. So you're going to be looking for two lines that are parallel and lines that have the same slope but have different y-intercept. So I'm just going to emphasize that here. different slopes for one solution, for no solution, same slopes, different y-intercepts. And here's an example where they have the same slopes. But they have different y-intercepts. Okay. And infinitely many solutions. This means that there are an infinite amount of points of intersection on the graph of lines. They intersect all the time. This happens anytime the slopes are the same and the y-intercepts are the same. Slopes are the same and the y-intercepts are the same. The lines will coincide or lie one on top of another. This is because they are exactly the same line. Even if they don't look that way, once you rearrange the terms, they're the same. Same slopes, same y-intercepts. Let's emphasize that. Same slopes, same y-intercepts. They're the same line. So here's our example. You're going to have to rearrange the equation to know that it's the same. This is the one we did before. We added 6x to both sides. 2y equals 6x minus 4. Divide everything by 2. And you end up with y equals 3x minus 2, which is the same exact line. Same line. Okay. All right, last up, we just have some matching. Match each graph on the left with the correct solution type on the right. One of them will be used more than once. So these two right here, they're never intersecting. They're parallel lines. That's going to be no solution. Parallel lines never intersect. All right, this one here is very tough to see the way it printed out. I am sorry, but let's see if I can go over it in highlighter maybe. We have this line, and then we have this line. Those are intersecting exactly once. Here, I'll go over it again. So they're crossing once. That's going to be exactly one solution. They are intersecting lines. All right, let's look at C. We have the line negative 2x plus y equals 3 and negative 4x plus 2y equals 6. All you can see is one line, but they're both labeled. This line is labeled with two different equations. So that means it's like there's having one on top of another. It's the same line written twice. They're intersecting constantly. That's going to be infinitely many solutions. Same line. One on top of the other. And then lastly, this one's a challenge one. I'm going to go over it in marker. We have this line right here that if I kept going would go out there. And then we have this line here that even though they're not intersecting right now, if you keep tracing them, they're going to end up intersecting. So because of that, it's one solution. So I'm just going to go over these because the lines are getting a little confusing. One solution. This one was also one solution. The parallel lines were no solution. And the lines on top of each other were infinitely many solutions. Okay. Make sure you can see all that. Okay. Last up, our higher order thinking. Are these three solution types the only types of solutions that system of linear equations can have? Is there any other solution type? Show an example on this grid below. So they have to be straight lines. So this is where you would brainstorm to see if you could ever draw two straight lines that are going to try and hit more than once, like 2 times. And drawing two straight lines, they can only have the options of crossing once, never crossing, or crossing constantly because they're on top of each other. So that's it. There are none. Are these 3 types of solutions the only types of solutions? So these 3 types of solutions, which are one solution, no solution, and infinitely many, are the only 3 possible types of solutions. Two straight lines can never intersect two times. So if you're thinking 2 solutions, it's impossible to draw 2 straight lines that are going to intersect 2 times. All right, so that's it for Thursday's lesson. Lesson 2, solving systems of linear equations graphically with special solutions. So just to recap, we went over one solution, no solution, and infinitely many solutions. All right, thanks for watching.